Good evening, dear students. This is Somu, faculty in ACE Engineering Academy. Today, in live session, we have preparation strategy regarding RCC. In this, I divided into two parts. One is how to prepare this subject and which type of questions will ask normally in AE level, right? These two things will take nearly 1 hour. Okay, please check till the end, listen till the end. Mostly questions will ask from this one only, right? Whatever here we'll discuss, more or less questions will come from this models only, right? Okay, coming to the weightage of this subject, actually it is given in 2015 only regarding RCC, not even considered concrete also. Only regarding RCC, 11 questions given. If you consider materials related to concrete itself, that is around 5 questions, more or less 15 to 16 questions you may expect from this subject. Okay, right. Coming to the syllabus, RCC structures, design philosophies, principles and concepts of working stress method and limit state method. My dear, you can expect the questions from this subject from both the methods, working stress method as well as limit state method. From both the methods you can expect. Don't ignore working stress method. You can expect questions from working stress method also because it is clearly mentioned in the syllabus. Coming to the next, loads and permissible stresses, IS specifications, analysis and design. Here you don't expect any designs, but you will expect design based questions like minimum steel, maximum steel, effective span, design load. This type of questions you may expect, right? Design for a rectangular beam, slab, T-beam, column, footing and staircase. This is a syllabus given for AE. Based on this syllabus, they will frame the questions. Questions mostly straightforward questions only, right? Yes, come to the preparation strategy regarding RCC. First priority you can give it for IS Codal Specifications because mostly questions will ask from code book, right? Minimum steel like maximum steel, minimum spacing, we will see, right? Yeah, here definitions, next simple definitions, 1-2 line definitions also you may expect in exam. After that you can give priority for concepts. First priority is for codal specifications, second priority is for definitions and third priority for concepts. Okay, fine. Then coming to the codal specifications. Here see the codal specifications, my dear. First thing, cover. For beams, what is the minimum cover provided? My dear, for slabs, what is the minimum cover provided? Similarly for columns and footings. Then minimum area of steel for beams, slabs, columns and footings. After that, maximum area of steel for beams, slabs, columns and footings. Minimum diameter and maximum diameter requirement for beams, slabs and columns. Minimum and maximum spacing for beams, slabs, columns and footings. Then assumptions, apart from this, under codal specifications only, assumptions under flexure as well as under compression. Then effective span of beams, side face reinforcement, deep beams, minimum number of bars, minimum eccentricity, minimum edge thickness of footing and minimum depth of foundation. My dear, these are the codal specifications, right? Main codal specifications. You will expect questions from these codal specifications, most of the questions. Coming to the next, definitions like what is effective depth, what is singly reinforced beam, what is doubly reinforced beam, what is a lever arm, characteristic load, characteristic strength, shear span, then what is column and what is pedestal, what is slenderness ratio, what is effective length of column, and what is aspect ratio. These are the basic definitions, just 1-2 lines only. If they are going to frame question in AE based on definitions, mostly from this only you can expect. Next one, concepts like types of sections, balanced section, under reinforced section, then over reinforced section, right? Then need of doubly reinforced beams, critical depth of neutral axis, compressive force, tensile force, lever arm, actual depth of neutral axis, moment of resistance, percentage of tension steel, stress block parameters, strain in compression steel, effective width of flange, nominal shear stress, tension steel in slabs, and load carrying capacity of column, critical section in footings, etc., etc. Right? Maybe they are going to frame a question based on this one also. Right? Yes. Majority of the questions you can get from Codal specifications, after that definitions. At the end, based on concepts also, 1 or 2 questions you may expect. Then before going to start, my dear questions, let me tell you, in a paper you have to follow EMD, means first you have to take up easy questions, then moderate questions, then difficulty questions. Right. Here difficulty questions means maybe lengthy questions or the questions which you don't know. Consider it is a difficulty question for you. Okay? That type of questions you have to take up at the end. First, easy questions. My dear, read the question paper. First question, if you know the answer, pick up. If you don't know, go to second question. Read the question. If you know the answer, pick up. Otherwise, move to next question. No need to write anything on paper. Right? That type of questions I consider easy questions. Just by seeing the question, I know the option A, B, C, D. These are easy questions. Without putting pen on paper, if I am going to pick up the option for the given question, that will be considered as an easy question for me. Then moderate question, I know the answer, but I want to substitute the values such that within one step I will get the answer. I can consider it is a moderate question. And more than 3-4 steps, if you are going to solve a question to get the answer, that will be considered as a difficulty question. Even the questions which you don't know, that one also I consider as a difficulty question. Okay? Right. Then almost all the faculty members told the same thing. Go early, at least 1 hour before you reach the examination hall. Don't take any tension in the examination hall. Right. If it is difficult, it will be for everyone, not only for you. Okay? And my dear, you need to pick up the options confidently, and to save the time, better to use elimination technique. Okay? Right. Come on, let us start the questions now. Modular ratio of M20 grade concrete is, options given here, A 7, B 10, C 13, D 20. Right. Modular ratio we know from strength of materials, E strong by E weak. In RCC we are using 2 materials, mainly steel and concrete. So we can write down E strong means E steel, that is Young's modulus of steel to Young's modulus of concrete, right? But this formula we are not going to use in working stress method. We are going to use an empirical formula, okay? That is M equals to 280 upon 3 sigma CBC. 280 upon 3 sigma CBC. Here given grade of concrete is M20. For M20 grade concrete, sigma CBC value is 7 megapascal. It is 7 megapascal, that is 280 upon 3 times sigma CBC is 7. So, you will get 280 upon 21, 280 upon 21. It is difficult for me to simplify. So, what I will do? I will go for approximation. 0, 0 cancel. Instead of 21, I have selected here 20. Nothing wrong. 0, 0 cancel. 2 1s are 2 14s are. 14 is not the exact answer. My dear, the correct answer is very close to 14. The correct answer is very close to 14. Is it more than 14 or less than 14? I selected here 20, which is less than 21. So, definitely I got here more value. So, correct answer is lesser than 14. Lesser than 14, very close to 14 is 13. Option C is correct. Okay? Then move to next question. As per IS 456-2000, minimum grade of concrete used in coastal area is, options given: A, M20, B, M25, C, M30, D, M40. In coastal areas, my dear, M20 is used in RCC in general construction. In general construction. Suppose if they don't mention in the question coastal area, simply asked what is the minimum grade of concrete used as per IS 456-2000, then option A is correct. But here mentioned coastal area, so in coastal area for RCC, minimum grade of concrete used is M30. Correct option is C. For the given question, correct option is C. Then next one, let me tell you one thing here. Maybe you will expect one more question from this. In M20 grade concrete, what is M and what is 20? Maybe we will expect the question, where M refers to mix and the number refers to characteristic strength. Characteristic cube. What is the size of the cube? 15 centimeter, or you can write 150 mm. Cube compressive strength of concrete. Cube compressive strength of concrete. Cube compressive strength of concrete after 28 days of curing. After 28 days of curing. Okay. So, we can write down here FCK equal to 20 Newton per mm square. Maybe this one also expected question. In M20 grade concrete, either M20 or M25, whatever it is, that letter M refers to mix and the number refers to characteristic strength. Okay. Right. The next question. As per IS 456-2000, maximum strain in concrete under axial compression, my dear, they are asking under axial compression. Options given: A, 0.0002, B, 0.0035, C, 0.0035 minus 0.75 times epsilon m, D, 0.0003. If you observe option D, it is the shrinkage strain in concrete. It is the shrinkage strain in concrete. As per IS 456-2000, shrinkage strain will be 0.0003. And option C, it is a strain in concrete, my dear, under axial compression and bending moment. It is the maximum strain in concrete under axial compression and bending moment. Now, option B, it is the maximum strain in concrete under bending moment. Under bending moment, it is the maximum strain in concrete. Then what is 0.002? It is the maximum strain in concrete under axial compression. Maybe you will expect question under axial compression, maximum strain in concrete under axial compression, or under bending moment, or under axial compression and bending moment, or shrinkage strain in concrete. Any one you may expect in exam. Okay, right. Next one, as per IS 456-2000, the design strength of concrete under bending in limit state method is very clearly mentioned in limit state method, design strength of concrete. Okay. Options given: A 0.36 FCK, B 0.4 FCK, C 0.45 FCK, D 0.5 FCK. My dear, 0.4 FCK is the design strength of concrete under axial compression. Under axial compression, design strength of concrete is 0.4 FCK. We use in columns, my dear, load carrying capacity PU equals to 0.4 FCK AC plus 0.67 FY ASC. Next, design strength of concrete under bending, it is 0.446 FCK. Under bending moment, we get design strength FD is equals to 0.67 FCK upon partial safety factor for concrete. When you simplify this, you will get 0.446 FCK. So, option C is correct. For this question, option C is correct. Okay? Then move to next question. The ratio of permissible bending compressive stress to permissible direct compressive stress in concrete in working stress method is, the question is, what is the ratio of permissible bending compressive stress to permissible direct compressive stress in concrete? How do you get sigma CBC? By taking factor of safety 3. How do you get direct compression? By taking factor of safety 4. Here FCK cancel, then you will get 4 by 3. 4 by 3. So, option D is correct. Option D is correct. Okay? Right. Next question. When earthquake or wind load is taken into account, the permissible stresses in working stress method are increased by, according to IS 456-2000, when the structure is subjected to either wind load or earthquake load, the permissible stresses in concrete as well as the permissible stresses in steel shall be increased by 33 into 1 by 3 percentage, or you can say 33.33 percentage, which is for economical design. Option A is correct. Next question. The factor of safety used for steel and concrete in working stress method respectively. Here also very clearly mentioned working stress method. Partial safety factor used in working stress method for concrete is 3, and for steel is 1.78. Let us take round figure 1.8. For steel 1.8 and for concrete 3. Here observe, first they have given steel, next they have given concrete, and they used word respectively, means you need to follow order. Okay. 1.8 first, next 3, 1.8 and 3, option C is correct. This is in working stress method. In limit state method, partial safety factor used for concrete is 1.5, The partial safety factor used for steel is 1.15. In these two, any one you may expect in exam, either under working stress method or under limit state method. Partial safety factors for materials you will expect in exam. For the given question, my dear, option C is correct. Under working stress method for steel, safety factor is used 1.8 and for concrete is 3. Sometimes they will ask definition also, be careful. Factor of safety, it is ultimate stress upon working stress. For brittle materials, factor of safety definition, yield stress upon working stress. For ductile materials, okay, right. Next question. In a singly reinforced beam, if the stress in concrete reaches its allowable limit earlier, important this word, earlier than the steel reaches its allowable value, then the beam section is said to be, it is a stress diagram. Stress in concrete reached to its allowable value. Here allowable value or permissible value is sigma CBC. By that time, stress in concrete does not reach to its permissible value. Now, which section is it? Actual stress in concrete reached to permissible stress, but actual stress in steel does not reach to its permissible stress. Which section is it? It is over reinforced section. Suppose if stress in concrete not reach to its permissible stress, but stress in steel reach to its permissible stress, it is under reinforced section. Where stress in concrete reach to permissible stress, even stress in steel also reach to its permissible stress simultaneously, then it is a balanced section. Here they are telling that stress in concrete reaches its allowable limit earlier, means first. Suppose if they use later, then here option will be changed. Okay. Anyway, for the given question, option C is correct. Okay. Right. Next, in an over reinforced beams, first failed is, which material is failed first in over reinforced section? My dear, since the stress in concrete reached to its permissible stress, so concrete failed first. In over reinforced section. Suppose if they asked for under reinforced section, stress in tension steel reached to its permissible stress first, so steel fails first. If it is a balanced section, stress in concrete reach to its permissible stress, even stress in tension steel also reach to its permissible stress. Hence, both concrete and steel fail simultaneously. Right. So here they asked over reinforced beam. So first fail is concrete. Okay, na? Right. Next question. Doubly reinforced beams are preferred. When do you prefer, or when do you recommend, or when do you suggest a doubly reinforced beam? Let us see the options given here. When the depth is restricted due to headroom, etc. B, when there is a chance for a stress reversal along the length of the beam. See, beam subjected to impact loads. My dear, no doubt, whenever the size of the beam or depth of the beam restricted either from architecture point of view or headroom point of view, concrete area will reduce. So, we need to increase steel area. That increased steel area distributed in both the zones, in tension zone as well as in compression zone. Then it will be a doubly reinforced beam, right? Yes. When there is a chance for stress reversal, since the tension developing above and below the neutral axis, so you must design the reinforcement in both the zones. Then beam subjected to impact load. Impact load is a shock load. Concrete alone cannot resist this. Hence, we have to design a doubly reinforced beam. In all the three cases, we can recommend a doubly reinforced beam. Option given D, all the above, yes, option D is correct. Okay. Next question. The stress strain curve of the concrete as per IS 456-2000. This code indicates limit state method, mainly limit state method. At the end given working stress method also, but mainly this code indicates limit state method. In limit state method, how is the stress strain curve of concrete selected? My dear, options given here: A perfect straight line up to failure, B straight line up to 0.002 strain value and then parabolic up to failure, C parabolic up to 0.002 strain value and then uniform up to failure, D linear up to 0.002 strain and uniform up to failure. See the stress strain curve of concrete as per IS 456-2000. This is stress axis, this is strain axis, and this is the design curve. Your strain is 0.0035 and at this level strain will be 0.002. My dear, it is parabola and it is rectangle or you can say uniform, right? Okay. Shape is parabola up to 0.002 strain, then constant or uniform till failure. Option C is correct. Okay, right. Next question. A simply supported beam is said to be a deep beam. Is said to be a deep beam if effective span to overall depth of beam is less than. My dear, we can decide whether it is a deep beam or not based on effective span to overall depth ratio. If effective span to overall depth ratio is less than or equal to 2 for a simply supported beam, then it is a deep beam. Similarly, for a continuous beam, if span to depth ratio is less than or equals to 2.5 for a continuous beam, then it is considered as a deep beam. Right, here they have given simply supported beam. So, L by D ratio must be less than 2, then only it is considered as deep beam. Otherwise, we can consider as a normal beam. Next question, right. As per IS 456-2000, the maximum strain in the tension reinforcement in the section at failure shall not be less than. My dear, tension reinforcement, it is very, very important, tension reinforcement. At the time of failure, what is the maximum strain in the tension reinforcement? See, this is the stress strain curve recommended by IS 456-2000. For the steel, it is Fy and it is a design curve 0.87 Fy. It is for CTD bars, the stress strain curve recommended for CTD bars, cold twisted deformed bars. For any deformed bar, identifying the yield point is highly difficult. That is why IS code recommended one procedure to select the yield point. How? See, take a standard strain 0.002 and draw one parallel line where it bisects. From there you mark it and there you have to project onto the stress axis. We know these two lines are parallel. So, here to here strain is 0.002, then absolutely from here to here also strain is 0.002 only. This is 0.002 and the strain from here to here. My dear, we know from basics E is equals to stress by strain, but I need a strain from this. So, strain is equals to stress by E. Do you know the stress at this level? It is 0.87 Fy upon E. For which material? Steel. So, this is the strain at this level. Now, this total strain indicates that steel will be failed at this strain. Okay? The steel will fail at the strain 0.002 plus 0.87 Fy upon Es. Here option, don't confuse, here 0.8 only given, that is why it is wrong. 0.0035 wrong and 0.0035 wrong, 0.002 plus 0.87 Fy upon Es. Option D is correct. Okay na? Right. Move to next question. For steel of grade Fe415, grade of steel given Fe415, the value of XU max upon D, where XU max is limiting depth of neutral axis. My dear, the limiting depth of neutral axis XU max is 0.53 D for Fe250 grade steel and XU max for Fe415 grade steel is 0.48 D for Fe415 grade steel and XU max is 0.46 D for Fe500 grade steel. Okay? Here they asked for Fe415. For Fe415 grade steel, XU max upon D, if you bring D left hand side, you will get on right hand side 0.48. Okay na? Right. Next question, my dear. Side face reinforcement is provided in a beam when depth of web exceeds. So, for example, you take a beam like this. For this beam, it is the width of the beam, it is the depth of the beam, right? Suppose if the depth is more than, this depth is more than 750 mm, then we have to provide side face reinforcement at mid depth, because maximum buckling occurs at a mid depth of the beam. So, we have to provide the side face reinforcement at mid depth. It is true when beam is subjected to flexure. Suppose if beam is subjected to torsion, when depth of web is more than 450 mm itself, we have to provide the side face reinforcement. But in the question they haven't mentioned whether beam is subjected to flexure or the beam is subjected to torsion. If nothing is mentioned, you can consider beam is subjected to flexure because it is a flexure member. If it is a torsion, 100% they will mention in the question. If nothing is mentioned, then you can consider beam is subjected to only flexure, then select 750 mm is the answer. Okay? In the question, if it is given torsion, option B is correct. Okay? Right. Next question. XU by D is greater than the limiting value of section is designed as. Here XU by D is greater than limiting value, means XU max upon D. Or you can write like this also, XU is greater than XU max. If it is a case, we can say it is over reinforced section. But we don't design over reinforced section because nature of failure is sudden. That is why we can suggest to go for redesign. Right? Option C is correct. Don't pick up over reinforced because they ask it is designed as. Suppose if the question is like this, XU by D is greater than the limiting value of the section, then it is. Definitely at that time you pick up option B. Then the section is over reinforced. Okay? But the question is which is designed as. We don't design. It is over reinforced section. So nature of failure is sudden. That's why we don't design it. Okay. Next question. The area of minimum tension reinforcement provided in beams as per IS 456-2000 is. Here given options A, AS upon BD equals to 0.85 upon Fy, B, ASV upon B into SV equal to 0.4 upon 0.87 Fy, 0.8 percentage of gross cross-sectional area and 0.12 percentage of BD. My dear, 0.12 percentage of BD is the minimum area of steel, in slabs as per IS 456-2000, in slabs, minimum area of steel. 0.8 percentage of gross cross-sectional area is the minimum area of longitudinal steel in a column. My dear, it is for columns. Minimum steel requirement for columns is 0.8 percentage of gross cross-sectional area. Then formula given in option B, ASV upon B into SV equal to 0.4 upon 0.87 Fy. Yes, it is minimum shear reinforcement in beams. Minimum shear reinforcement formula for beams is ASV upon BSV. Minimum tension steel they asked in beams, so option A is correct. Maybe you will expect one from these four options, either this or this or this or this, any one you will expect. Okay, right. I hope you are following. Any doubts? Any doubts? Are you getting? No one. Good evening, sir. Good evening, sir. Only wish is there. No doubts here. Okay, my dear. We will continue. We will continue. Next question. The area of minimum tension reinforcement of Fe 250 steel in a 250 mm wide beam of 400 mm effective depth is. Question is, what will be the minimum area of tension steel provided in beams? Minimum area of tension steel provided in beams is determined from this formula recommended by IS code. AS upon BD equals to 0.85 upon Fy. We want AS. Remaining data given, where B, width of the beam given 250 mm and depth of the beam given 400 mm equal to 0.85 upon Fy. Yield stress, my dear, given grade of steel is Fe 250, for which yield stress is 250 Newton per mm square. Now write down here 250, right, 250 gone. Then AS equal to 0.85 into 400. My dear, that is 85 upon 100 into 400. 2 zeros gets cancelled. 4 5s are 22. 4 8s are 32 plus 2, 34. 340 mm square. Option D is correct. Simple question, right? Okay, move to next question. Here. The area of maximum tension reinforcement in beams as per IS 456-2000 is. Maximum tension reinforcement in which member? In beams. You know, my dear, given options here, A 2%, B 4%, C 6%, D 8%. There is no 8% limit from IS code. There is no 2% limit from IS code regarding maximum steel. My dear, maximum tension steel in beams. This is the beam cross section. In beam cross section, say this is a neutral axis, say above neutral axis compression, below neutral axis tension, maximum how much steel you can design according to IS code, it is 4%, right. Similarly, minimum compression steel also you can design in beams is 4%, right. Even maximum compression steel in beams is also 4%, okay. Then what about maximum steel in slabs? Same 4% only. Regarding columns, my dear, for beams and slabs, maximum steel requirement is same 4%, but in columns, maximum steel provided, that is longitudinal steel, will be 6% of gross cross-sectional area, okay. Right, option C is correct, sorry, for beams na, option B is correct ma. For beams and slabs, maximum steel requirement is same 4%. Sir, what about regarding footings? Footing is nothing but inverted slab. It is same as that of slab requirement only, 4%, okay. Right. Coming to the next question, the main reinforcement to be provided in a cantilever beam is at, beautiful question, A, bottom, B, top, C, neutral axis, D, anywhere in the section or anywhere in the beam. This is cantilever beam. This is cantilever beam. It is longitudinal axis. You know, when we apply load on cantilever beam, it will undergo hogging curvature. So, above longitudinal axis, tension will develop. Below longitudinal axis, compression will develop. As concrete is weak in tension, so we have to provide main steel in a cantilever beam along the length. Along the length we have to provide. Right, at the top is the correct answer, at the top. Suppose in place of cantilever beam, if it is given simply supported, definitely option A is correct. Option A is correct, okay, right. Because for a simply supported beam, tension will develop at bottom, na, right, okay. Come to the next question. The distance between extreme compression fiber and centroid of tension steel is, good question. Options given, overall depth, B, effective depth, C, lever arm, D, width. Suppose you take a beam, the shorter dimension we have to take generally width of the beam, right, and this dimension we have to taken as overall depth. See, this is a neutral axis, above neutral axis compression, below neutral axis tension. So, it is a extreme compression fiber, it is a extreme tension fiber. The distance between extreme compression fiber and extreme tension fiber is overall depth of the beam, right. And this is the steel reinforcement in tension zone, we call it as a tension steel, and it is a centroid of tension steel, and this is the effective depth of the beam, it is the effective cover to tension steel. Here the question is, the distance between extreme compression fiber and centroid of tension steel, that is the effective depth of the beam. Overall depth of the beam, capital D, effective depth of the beam, small d, lever arm, my dear, I will tell you what is lever arm, that is Z, and width of the beam is B. What is lever arm? Suppose if you take the stress diagram in limit state method, it is partly rectangle then partly parabola. You know the compressive force is acting within a rectangular portion of stress block and tensile force is acting at the centroid of tension steel. Now the distance between compressive force and tensile force is the lever arm. Lever arm is the distance between compressive force and tensile force. Here effective depth is the distance between extreme compression fiber and the centroid of tension steel. Overall depth is the distance between extreme compression fiber and extreme tension fiber. Okay? Right. Option, which option is correct? Option B is correct. The next question, the maximum strain in compression steel of a doubly reinforced beam is 0.002 into 1 minus d dash upon xu, B 0.0035 into 1 minus d dash upon xu, C 0.002, D 0.0035. My dear, see here, this is a strain diagram. It is neutral axis position. Above neutral axis, this is a strain diagram, only above neutral axis I have drawn here. And strain will be at this level, say 0.002, and strain in concrete at extreme compression fiber under flexure is 0.0035. At this level we have to provide the strain in compression steel. What happened, my dear? Is it okay? Right. Any doubts here? Okay. Very good, nice. You are picking the options. Super, very good. Sir, give clarity which is used in exam, limit state or working stress method. Devi Sunil. Madam Devi, I told in the beginning of the session, once again I will tell you, questions will ask from both the methods because it is mentioned clearly in the syllabus, working stress method as well as limit state method. Is it okay? Right. If not mentioned in AE, I will show you at the end once again the syllabus part. Okay, don't worry. Right. Working stress method also mentioned in the syllabus. Okay. Here most of the students are going to pick up the options, right? Sir, give clearly. Yes. Same thing. Venu, stress, working stress method, strain, limit state method. Chandu, Naik. Very good. Most of the students are responding to this. Very good. Good. Keep it up. Keep it up. Before I am going to pick up the option, my dear, try to pick up. Okay? Because already you have attended classes. I hope you will answer. No doubt. Yes. Sai Teja, you have picked up the option. Very good. And very good. Good, 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 good. Wow. Nice. Good. Okay. See here, what is the question? Strain in compression steel, right? Strain in compression steel. How do you get this? You know, this distance be the effective cover to compression steel. At this level, we want the strain. My dear, this is say XU. For balanced section, we have to write XU max. For under reinforced section, we write XU. We want epsilon SC. Very simple, my dear. From similar triangles, we can find out this. See, this distance is XU minus D dash. It is XU minus D dash. Okay. I can write down epsilon SC upon 0.0035 from similar triangles. See, this is one triangle. This is another triangle. Okay. Now, for epsilon SC, what is the distance? XU minus D dash upon. For 0.0035, what is the distance? It is XU. I want epsilon SC, that's all. That is 0.0035 into XU upon XU 1 minus D dash upon XU. Now, which option is correct? Option B is correct, right? Yes. Fine. Come on, my dear. Next question. Are you ready? Are you ready? Yes. A doubly reinforced beam is considered less economical because, be ready. Option A, tensile steel required is more than that of a balanced section. B, compressive steel is under stressed. C, shear reinforcement is more. D, concrete is not stressed to its full value. Which option is correct? Which option is correct? Very good, very good. Ramavat Ravi, Govardhan, Ravi, come on my dear, pick up the correct option. The correct option for this question is compressive steel is under stressed, or you can say compression steel is not utilized fully, right? FSC value is less than 0.87 Fi. We are not going to utilize the compression steel effectively. That's why as compared to singly reinforced beams, the doubly reinforced beams are uneconomical. Okay, right. So option B is correct. Then move to next question. Come on, be ready. What is the assumption in the steel beam theory of doubly reinforced beams? Options given: A, only steel bars will resist tension. B, only concrete resist tension. C, stress in tension steel equal to stress in compressive steel. D, both concrete and steel will resist compression. Come on, my dear. Yes. Lalita madam. Then Vinay. Then Banjara Creations. Shivani. Very good. Very good. Very good. What is the assumption in steel beam theory? First of all, let me tell you, not all doubly reinforced beams. There are few doubly reinforced beams behave like steel beams. See, that means the tension steel act like a flange and the compression steel will act like a flange and concrete in between act like a web. Overall, it will act like a steel beam. According to steel beam theory, it is only assumption, my dear, that the stress developed in tension steel must be equal to stress developed in compression steel. Which option? Option C is correct. Option C is correct. Then move to next question. As per IS 456-2000, the effective width of flange for a T-beam is, options given here: A, L0 upon 6 plus BW plus 6 DF, and option B given L0 upon 12 plus BW plus 3 DF, C given L0 upon B plus 4 plus BW, D given 0.5 L0 upon B plus 4 plus BW. Which option is correct? Come on, my dear, pick up. Very good, very good. Very good. Prashant, Sheshu, Sindhu. Very good, nice. Govardhan, Sridhar. What about other students? Very good, very good. Yes, Mr. Tirupati, your answer is correct. Very good, ma. Nice. Super. See here, they haven't mentioned that it is isolated T-beam. Simply it is given T-beam, right? For a T-beam, effective width of flange formula recommended by IS code is L0 upon 6 plus BW plus 6 DF. For L beams, effective width of flange formula recommended by IS code is L0 upon 12 plus BW plus 3 DF. And for isolated T-beam, Effective width of flange formula is L0 upon B plus 4 plus BW. For isolated L beam, it is an empirical formula recommended by IS code 0.5 L0 upon B plus 4 plus BW, right. Easy to remember, my dear. This is the T and this is the L. That means half of the T is nothing but L. See, if you remember this formula, then for L beams, half means L0 by 12. Don't disturb BW, okay. 6 DF na half means 3 DF. Similarly, for this case also, if you write here 0.5, that will be the formula for isolated L beam, okay. Right. For this question, option A is correct. Then move to next question. Be ready. Minimum time period for a vertical formwork to columns. Given here options A 1 day, B 3 days, C 7 days, D 28 days. Come on, my dear. Chandu, which option is correct? Deepka madam, Pavane madam, tell me. Which option is correct? What, Mr. Sai Teja? Venki? Good, nice, 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 super, very good, very good. As per IS 456-2000, for columns, to remove the vertical formwork, that is nothing but molds given to the members to fill the concrete, right. How much time you are going to take it? Even, my dear, to support that sheets, we have to provide timber sticks. Technically, we call it as, my dear, what is it called? Props. For columns, 16 to 24 hours required. Let us say 1 day. Then, what about for slabs? To remove the formwork, it requires 3 days. It requires 3 days. My dear, once after removal of sheets to the slab, we have to refix the props. Okay. Then for beams required, it is 7 days. 7 days required. Once after removal of the formwork, we have to refix the props. Then coming to the next slabs. For slabs, when span is up to 4.5 meters, here we have to remove the props. 7 days required. It is 7 days. My dear, if span is more than 4.5 meters for slabs, the props we have to keep up to 14 days. After 14 days, we have to remove it. Coming to the beams, how many days required to remove the props? If span is up to 6 meters, my dear, required 14 days. 14 days. And if span is more than 6 meters, required 21 days. Required 21 days. Here they asked for columns to remove the vertical formwork. My dear, option A is correct. Okay. Right, good. Very good. Nice, nice. Now we will move to next question. Okay. Come on, my dear. A T-beam behaves as a rectangular beam of width equal to its flange if it's a neutral axis. Options given: A, coincides with the centroid of reinforcement. B, coincides with the centroid of T section. C, remains within the flange. D, remains in the web. Come on, my dear, I hope you can, Chandu. Very good, very good. What about other students? Respond to the question. Pramod, no need to type the, my dear, answer. You just pick up the option. 4 options are there, right? Good, 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 good. Very good, Prashant, JK. then Shajia, Pramod, Madhu, Vishnupriya, Kishore, good, good, very good. Nice response, nice response. My dear we engineers, please check your option. Anil Kumar, good. Very good, super. Nice response, nice response. Right. Okay. Let us see now. See, good. My dear, when do you treat a T-beam like a rectangular beam? See, this is a T-beam. Okay. Consider the neutral axis position within the flange. This is neutral axis position. Say above neutral axis compression, below neutral axis tension. So we have to provide a steel reinforcement in the tension zone. Okay. We have to provide a steel reinforcement in tension zone. This is tension steel, its area be the AST. Now what is the effective area? Effective area I want. Effective area above neutral axis. Below neutral axis, effective area will be only steel area. In tension zone, I am least bothered about the shape. My dear, we have to consider in compression zone only shape. What is the shape available above neutral axis? It is a rectangle. So we can treat either for analysis or for design a T-beam like a rectangular beam when neutral axis lies within the flange. Suppose if neutral axis lies within the web, then we can treat it like a flange section only. Suppose this is another T-beam I am going to consider. This time I am going to take neutral axis in the web. My dear, if you see here, this is a steel reinforcement. Now this shape is like a flange section, right? Whenever neutral axis lies in the web, you can treat it like a T section. Whenever neutral axis lies within the flange, you can treat it like a rectangular section either for analysis or for design. Okay. So correct option is remains within the flange. Neutral axis lies within the flange, then we consider a T-beam like a rectangular beam. Ready? Next question, ready? Be ready. An RCC beam of 200 mm by 300 mm effective, the given one is effective depth, is subjected to a factored shear force 30 kilonewton. The maximum nominal shear stress in Newton per mm square as per present code is options given: A 0.5, B 0.55, C 0.75, D none. Come on, my dear, who pick up the correct option? We will see. Come on, pick up. Which option is correct? Do it. I am waiting for your reply. Okay, good. Nice. Super. Very good. Good. Nice. Great. Okay. See, my dear, they are asking nominal shear stress tau V. Tau V equal to VU upon BD. This formula we can write if the beam has uniform depth. If the beam has varying depth, we have to use another formula, that is tau V equal to VU plus or minus MU upon D times tan beta upon BD. This formula is used for uniformly varying depth of beams, and this formula is used for uniform depth of beams. Now they have given simply depth, so you have to consider it is uniform depth of beam. Maybe in exam you may expect this formula, not a numerical question. Okay, right. What is VU given in the question? It is given 30 kilonewton. Let us write in Newton, 30 into 10 cube upon B. B given here 200 mm and D given here 300 mm. Easy to simplify. How many zeros are there in numerator? Here 3 zeros, here 1 zero. Total 4 zeros. 4 zeros gone. Then 3 gone. 1 by 2 is remaining. 1 by 2 means 0.5. 0.5 Newton per mm square is answer. Option A is correct. Option A is correct. Good. Then move to next question. Next question. If the nominal shear stress tau V at a section does not exceed the permissible shear stress tau C, options given: A, minimum shear reinforcement is still provided; B, shear reinforcement is provided to resist the nominal shear stress; C, no shear reinforcement is provided; D, shear reinforcement is provided for the difference of the two. Which option is correct? Come on, my dear, pick up. Come on, I am waiting for your response. Yes, Mr. Sheshu, Shiv Kumar, Vishnu Priya, Pramod, Kalyan, Shajia. Very good, very good. Good. Super. Still you need to maintain speed. Speed and accuracy both are equally important, my dear, in competitive exams. Here they have given that tau V is less than tau C. Then what to do? My dear, when tau V less than tau C, the section is safe from shear point of view. Though it is safe, still we have to provide minimum shear reinforcement, which is to keep the main steel in position, to take care of secondary effects, to increase the ductility of the beam, and to confine the concrete. For these reasons, we have to maintain still minimum shear reinforcement. Okay? Suppose if tau V greater than tau C, then we have to design the shear reinforcement, maybe vertical stirrups or inclined stirrups or combination of bent up bars and vertical stirrups. But condition given tau V less than tau C, so section is safe, but still we have to provide minimum shear reinforcement. Option A is correct. Very good, very good. Next question. The permissible shear stress in concrete for beams without shear reinforcement depends upon options given: A, percentage of tension reinforcement; B, grade of concrete; C, both of the above; D, none. Come on, my dear, which option is correct? Which option is correct? Here given 4 beautiful options. I hope you will answer. Come on, which option is correct? Respond quickly. Venkatesh, Govardhan, Uma Mahesh, Shajia, Nagendra, Sheshu, Malesh, Pramod, Satish. Very good. Nice response. Very good, very good. Here, my dear, you have to observe what is the shear stress in concrete without shear reinforcement. We have 2 permissible limits. One is a tau C, another one is tau C max. Tau C max is measured with shear reinforcement. Tau C is measured without shear reinforcement. So, it depends upon 2 things. One is concrete grade and percentage of longitudinal tension steel. But tau C max depends on only concrete grade. Only concrete grade. But here given without, so it is a tau C. Tau C depends on both. Option C is correct. Option C is correct. Then move to next question. The maximum spacing of vertical stirrups in a beam as per IS 456-2000 is options given: A, 0.75D or 300 mm, whichever is smaller; B, D or 300 mm, whichever is smaller; C, 1.25 times D or 300 mm, whichever is smaller; D, 1.5D or 300 mm, whichever is smaller. Come on, my dear, which option is correct? Sai Krishna, Deepika, Come on, Vishnu Priya, Nagendra, Vinay, Pramod, Divya, Abhinav. What about other students? Where is the competition, my dear? Come on. You have to answer first always. I will read only first 3 students. Okay? Come on. So, here they asked for vertical stirrups. For vertical stirrups, maximum spacing should not be more than, that is 0.75D or 300 mm, whichever is smaller, maximum spacing for vertical stirrups. For inclined stirrups, D or 300 mm. It is for inclined stirrups. For inclined stirrups, D or 300 mm, maximum spacing. For vertical stirrups, .75D or 300 mm. Option A is correct. Then move to next question. The lap length in compression is not less than, options given: A, LD or 30 times bar diameter, 2 times LD or 30 times bar diameter, C, LD or 24 times bar diameter, D, 2 times LD or 24 times bar diameter. Right. Come on, my dear. First 3 persons. First 3 persons. First 3 persons. Very good, very good. TSPSC aspirant, Kishore and G Root. Okay, these 3 persons picked up the answer first. Let me tell you the correct one. In compression, my dear, in compression, here LD or 30 times bar diameter, it is under flexural tension, lap length under flexural tension. 2 times LD or 30 times bar diameter, it is under direct tension, lap length. Under compression, which compression? Any compression, whether it is axial compression or bending compression. For any compression, lap length should be LD or 24 times bar diameter, whichever is maximum. Option C is correct. Option C is correct. Come on, my dear. Next question, be ready. Be ready, next question. I will read only first 3 students' names. Come on. Who will answer first? Who will answer first? The question is, for full anchorage, the stirrups should extend by a length of dash times the diameter of the bar when bent at 135 degrees. Options given: 4-5, B, 8-5, C, 12-5, D, 6-5. Which option is correct? Quick. TSPSC aspirant, Uma Mahesh, G Root, Vishnu Priya. Last time you got 4th place. This time also you got the 4th place. Let's try to get the first place. Okay, come on. 135 degrees bend, my dear. See, for stirrup 135 degrees bend, we have to provide 6 times bar diameter. Let me give you, for 90 degrees bend, 8 times bar diameter, and 135 degrees bend, my dear, it is 6 times bar diameter. For 180 degrees bend, it is 4 times bar diameter. It is for stirrups. Let me give you for a tension steel, a 45 degrees bend, 4 times bar diameter, and 90 degrees bend, 8 times bar diameter, and 135 degrees bend, it is 12 times bar diameter. 180 degrees bend, it is 16 times bar diameter. It is also called, this 180 degrees also called standard U-type hook. Standard U-type hook. Maybe you can expect this, or you can expect this, or you can expect this one. In these 3, any one you will expect in exam. Okay? Right, very good, very good. Come on. Option D is correct for this question. Then move to next question. Go to next question. Once again, be ready. Which one of the following statement is correct? Here given, in a reinforced concrete member, the best way to ensure adequate bond is options given: A, to provide minimum number of large diameter bars; B, to provide large number of smaller diameter bars; C, to increase the cover for reinforcement; D, to provide additional stirrups. Who will answer first? Uma Mahesh, Shajia, then TSPSC aspirant. Very good, Mr. Uma Mahesh. My dear, if the section is not safe in bond, the best way is selecting smaller diameter than design diameter, such that we get more number of bars. As number of bars increases, surface area increases. When more surface area will be in contact with the concrete, then automatically bond stress will increase. Okay, clear na? Right. So option B is correct, to provide large number of smaller diameter bars. Number of diameter is smaller, number will be more, so surface area will be more, so bond stress will be more. It will satisfy the bond criteria. Right. Then move to next question. Equivalent shear force for beams VE is given by VU plus 1.6 TU upon B, B, VU plus 1.7 TU upon B, C, VU plus 1.8 times TU upon B, D, VU plus 1.9 TU upon B. Which option is correct? Be ready, be ready. Who will be the first person? Who will be the first person? My dear, this time Pavani? No, Uma Mahesh. Once again, Uma Mahesh is the first person, then TSPSC, then G Root, then Vishnupriya, then Sanju, then Chandu. Come on, my dear. The correct answer is option A. It is an empirical formula. For equivalent shear force, VE equals to VU plus VT. That can be written as VU plus 1.6 TU upon B. Maybe they will ask this formula, or they may ask equivalent bending moment, ME equal to MU plus MT, where MU is the factored bending moment, MT is the moment due to torsion, that is TU into 1 plus capital D by B upon 1.7. Be ready for the next question. As per IS 456-2000, minimum area of steel in slabs if mild steel is used. Who is the last person now? Namrata. Okay, we'll see who is the first person. Come on. Options given: A 0.34%, B 0.24%, C 0.15%, D 0.12%. Chandu. Good, 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 good. We engineer. Then it's me. Akhil. Very good, very good. I think Chandu is not answered correctly, and even Akhil is the first person answered correctly to this question. Mahesh, this time your answer is wrong. Here clearly mentioned mild steel. In slabs, minimum steel they are asking. My dear, for HYST bars, minimum steel will be 0.12% of BD. If mild steel is used, minimum area of steel recommended by IS code is 0.15% of BD. B is the width of the slab, where capital DB is the thickness of the slab. Okay, my dear, then we'll move to next question. Be ready, be ready, be ready. Very good, Very good, very good. Next question. The maximum spacing of main reinforcement in slabs as per IS 456-2000 is, come on my dear, which one is correct? Option A, B, C, D given, 4 options given, come on. Who is that? Harish, Sultan, very good, very good, very good, good. Nice, super. My dear, they asked the maximum spacing for main reinforcement in which? In slabs. It is 3D or 300 mm. It is the correct answer. Suppose if they asked for a distribution steel instead of main steel, if they asked for a distribution steel, 5D or 300 mm is the correct answer. For a distribution steel, maximum spacing will be 5D or 300 mm, whichever is smaller. For main steel, 3D or 300 mm, where D is the effective depth of the slab. Okay. Move to next question. Very good, nice response, great response. Let us see the next question. As per IS 456-2000, maximum diameter of steel bars used in slab. Options given A, B, C, D. Anil, okay, let me tell you here 2 doubts. Actually, Bhaskar is a one person and another person Anil and Sanju. Yes, my dear, in 2000 actually given the maximum spacing will be 5D or 450 mm, okay. But later on it is modified, my dear, it is given that 300 mm. It is not 450 mm, it is modified to 300 mm later on in 2007, okay. We have a proof, don't worry, 300 mm is the correct answer, okay, right. Come on, my dear. Fine, very good, nice. Here, maximum diameter of steel bar used in slab, my dear, it is 1/8 of overall thickness of the slab. In slabs, maximum diameter should not be more than 1/8 of overall thickness of the slab. In slabs. Whereas in beams, minimum diameter requirement, it is not less than 12 mm. In columns, minimum diameter requirement is there, it is not less than 12 mm. In beams, in columns, for longitudinal steel, minimum diameter 12 mm. For a transverse steel, what is that, lateral ties or helical reinforcement, diameter 6 mm, okay. Anyway, the question is regarding slabs, maximum diameter should not be more than 1/8 of overall thickness of the slab. Option C is correct, right. Next question, be ready. The minimum thickness of a flat slab required according to IS 456-2000 is, my dear, options given A, B, C, D. Which one is correct? I am waiting. Good, nice, super. Who is that person? Ganesh, Kavita, Mirza, Uma Mahesh. Very good. Pick up the option. No need to type it. Waste of time only. As per IS 456-2000, the minimum thickness of flat slab is 125 mm. Okay. Right. Next one. Option A is correct. Next question is, the torsional reinforcement in a two-way restrained slab required for a corner with the 2 continuous edges will be Suppose if you take the slab like this, it is divided into number of panels, right? Take one panel, right, and take corners A, B, C, then D. My dear, at corner A, both edges are discontinuous. At corner B, one edge continuous, another edge discontinuous. At corner C, same as B, one edge discontinuous, another edge continuous. At corner D, both edges are continuous. They have given so clearly with two continuous edges here. They are asking at corner D. According to IS code, at any corner, if two edges are discontinuous, provide a torsion steel of magnitude 3/4 of ASTXX in each direction, 3/4 of ASTXX. At any corner, if one edge is discontinuous, another edge continuous, provide a torsion steel of magnitude 3/8 times ASTXX. At any corner, if both edges are continuous, no need to provide the torsion steel, nil. Nil. So, the question is related to corner D, no need to provide the torsion steel. Okay? Right. Next question. Next question. The permissible value of deflection for a two-way simply supported slab with a shorter span less than 3.5 meter and live load is less than 3 kilonewton per meter square using deformed bars is. My dear, which option is correct? Which option is correct? Which option is correct? Good, 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 nice, great. My dear, L by D value for a two-way slabs is 35 if it is simply supported slab, that too with a mild steel. Suppose if it is deformed bar, clearly mentioned here using deformed bars, multiply with 0.8, you will get 28. L by D value for a two-way slab, if it is continuous slab, if it is continuous slab, it is 40. If you want for a HYST bars, simply multiply with 0.8, you may get 32. My dear, option B is correct here, right? Okay, then move to next question. Move to next question. The minimum number of bars in a circular RC column as per IS 456-2000 is, it is a common question in competitive exams, my dear. Which option is correct? Which option is correct? I hope you will answer. Which option is correct? Which option is correct? Right. See, in a rectangular column, minimum numbers 4. In a circular column, minimum numbers 6. In octagonal column, minimum numbers 8. That is 1 at each corner. But this is not there. Question is regarding circular column, so option B is correct. The next question. An axially loaded column is of 300 mm and square in section. The effective length of column is 3 meter. What is the minimum eccentricity of the axial load for the column? Options given here A, B, C, D. My dear, minimum eccentricity, in worst case we have to take 20 mm. If I observe the options A 0, B 10 mm, C 16 mm, D 20 mm, only one option is there 20 mm. If any option given above 20 mm, then I need to think. But here no option is given above 20 mm, then definitely I can pick up the option without any calculation. Suppose if you want to calculate, yes, you can do like this. E minimum equals to unsupported length of column upon 500 plus lateral dimension upon 30 or 20 mm or 20 mm, whichever is maximum, whichever is maximum. In this question, they have not given unsupported length, they have given effective length of the column, but support conditions is not given. So, you need to consider unsupported length as the effective length, that is 3 meters given, write down in mm, 3000 upon 500 plus B given 300 mm, simply write down here upon 30. Now, simplify 30 ones are 30 tens are, here 2 zeros, 5 ones are 5 6 are, total you will get 16 mm. Compare with the 20 mm, select the maximum of these two. So, maximum is 20 mm. So, E minimum for this question, only for this question is 20 mm, right. If data change, definitely the values will change, okay my dear, right. Then move to next question. Next question. The purpose of lateral ties in a short column is to increase the load carrying capacity of the column, avoid buckling of longitudinal bars, C, facilitate construction, D, increase the shear strength of concrete. My dear, the main purpose of lateral ties in a column is keeping the main steel in position, that is avoiding buckling of longitudinal steel bars. Option B is correct. Then move to next question. The minimum thickness required at the edge of a footing according to IS 456-2000 is, minimum edge thickness will be, my dear, they have not mentioned here whether footing is resting on soil or footing is resting on piles. If nothing is mentioned, you know the values, my dear, 150 mm and 300 mm. Let us select the least value here, okay. So, 150 mm. If footing is resting on soil, minimum edge thickness will be 150 mm. Suppose if footing is resting on piles, then minimum edge thickness will be 300 mm. Luckily, not given 300 mm in the options. Suppose if 300 mm also given, then we know least value is 150 mm. So, we have to pick up 150 mm. Minimum edge thickness they ask. That is why we have to pick up option B. Then move to next question. In case of isolated square concrete footing, match location at which the stress resultant are to be checked. Option C, here question given. Under, my dear, list 1 given, bending moment, one way shear, punching shear. Under list 2 given, at the face of the column, at D by 2 from the face of the column, at D from the face of the column. Options given A, B, C, D. My dear, where is the critical section for bending moment? Exactly at the face of the column. Where is the critical section for one way shear? At a distance D from the face of the column. Then where is the critical section for punching shear? At a distance D by 2 from the face of the column. So, P1, Q3, R2, 132, option C. But I am not expecting the question like this in AE. Maybe I am going to expect any one only. The critical section for bending moment when footing supports to RC column lies at, options given, at the face of the column, at a distance D from the face of the column, at a distance D by 2 from the face of the column, at a distance D by 4 from the face of the column, like that options you may expect, right. Okay. Next one. The permissible bearing stress for M20 grade concrete column resting on a rectangular concrete footing in limit state method of design should not be more than, my dear, we know permissible bearing stress FBR is 0.45 FCK in limit state method, that is 0.45 into 20, you will get 9 megapascal. Suppose if the question is asked in working stress method, then it is 0.25 FCK. In working stress method, permissible bearing stress is 0.25 FCK, in limit state method 0.45 FCK. Option B is correct. Option B is correct. The next question, my dear, match the list 1 with list 2 once again. Match the following type. Right. Under list 1 given flexure, shear, bond, deflection. Under list 2 given minimum depth of section, longitudinal steel, stirrups and anchorage. My dear, to resist the flexure, we have to design longitudinal steel reinforcement. Okay. Next, to resist the shear, we have to design the stirrups. Next, to satisfy the bond criteria, we have to provide anchorage. To satisfy the deflection, we have to maintain minimum depth of the section. So, 2, 3, 4, 1, 2, 3, 4, 1, option D is correct. Option D is correct, okay? Right. Next question. Okay. A cantilever slab is of span 1.4 meter. The thickness required from the serviceability criteria is, my dear, to satisfy the serviceability criteria, we have to take L by D ratio. For a cantilever, it is 7. So, D is equals to L by 7. What is the L given here? 1.4 meter. So, you will get 0.2 meter. But options given in mm, I can write in mm. Simply multiply with 1000. 200 mm. Option A is correct. Next question. Minimum number of steps in a flight should not be less than, options given, A 3, B 5, C, actually it is option C, 7, D 9. My dear, in a flight minimum number of steps 3, maximum number of steps 12. In one flight, minimum 3, maximum 12. So, they asked minimum, option A is correct. The next question, number of treads in a flight should be equal to number of risers plus 1, number of risers minus 1, number of risers minus 2, exactly equal to number of risers. See, my dear, for easy understanding, it is the landing slab, it is the riser, tread, riser, tread, riser, tread, riser, landing, riser, tread, riser, tread, riser, tread, riser. Now count 1, 2, 3, 4, 4 risers, okay. Next treads 1, 2, 3, 3 treads, okay. Now what is the relation between riser and treads? Number of treads is equals to number of risers minus 1. Option B is correct, okay na? Right. Next question, my dear. Which of the following code used for loads to design? Options given, my dear. A, IS 456. This is for plain concrete and reinforced concrete. Code of practice for plain concrete and reinforced concrete, RCC. IS 800, it is for steel design. IS 875 for loads. IS 1343, it is for pre-stressed concrete. IS 1893, it is for earthquake load. Any one code you will expect in exam, right? Here for loads na, option C is correct. I am sorry, option C is correct, right? Next one, the minimum depth of foundation is given by Rankine. Actually formula here not given, directly I am writing minimum depth of foundation is P by gamma into 1 minus sin phi upon 1 plus sin phi whole square. Don't forget square. In options, they will miss the square, okay? Right. I wish you all the best. I hope you enjoyed the session. More or less questions will ask like this only. Some of the questions as it is you will expect in exam, right? Now you can ask if you have anything, you can share your feelings, your views. How is the session? Not gamma square. Pramod, thank you, sir. Chandu. Okay. Still, any doubts here? I wish you all the best. God bless you. I hope you will get AE, right? My dear, don't relax, don't relax. We have very less time. Let us check it, the questions, my dear, as many questions as possible, right? You have written test series by this time, even material questions you have to revise, right? I wish you all the best once again. Love you, sir. Love you too. All the best.